quadratic equation, root of quadratic equation. That's what we are going to do. Forming the quadratic equation when the roots are given. At first, we were solving the quadratic equation to get the roots, that's the s values. Now, they will give us the s values and they will ask us to form the equation. So, since here we don't know our s, we will let our s1 will be alpha and our s2 will be beta. So if s1 equals alpha and s2 equals beta, then if you equate it to 0, so it will be s minus alpha, then s minus beta equals 0. So if the roots are s equals alpha and s equals beta, then our equation is s minus alpha times s minus beta equals what? 0. Right. So now let's simplify this one. So we can use the distributive property to do that one. So s multiply this and negative a multiply this. So or we take one after the other. So s times this s is s squared. Then s times negative beta is minus s beta. Then negative alpha times s minus negative alpha. So that's what we are saying here. So s squared, s times s squared, then s times negative beta is what? Minus beta. Negative alpha times s is what? Negative s alpha. Then negative alpha times negative beta. Again, forget. So that's why we got the positive here. So alpha beta equals 0. Right? So what should we do here? This s square, we have s here, so let's factor the s out here. If factor the s out here, we got alpha plus beta, right? That's all, beta minus alpha. So alpha plus beta. Because if negative s times alpha, we got negative alpha s. That's what is here. Negative s times beta, we got negative beta. That's what is here. That's how you factorize it. The negative will come outside, and here will be what? Positive. Because if we multiply to here will be negative, right? Then we have for alpha beta. So this is what we call our root of quadratic equation. So when you are forming, so s squared minus s, alpha plus beta is the sum of roots. That's why I say it's the sum of roots. So alpha plus beta is the sum of roots. And product of roots is alpha times beta. So this one is the product of root, sum of roots. So this is how we prove for the forming the quadratic equation. So let's solve some example under this. Form the quadratic equation given the roots, right? So sum of roots. So this alpha and beta. And we say our sum of roots. So we have to form the quadratic root. So this alpha and what? Beta. So sum of roots. It means that you add this. So if you add this, you get 11 out of 3. Then you find out product of roots. Product of roots, we what? We multiply this times this. You get 2. Then we substitute it into our equation. So the equation is s squared minus, when we are proving, so that they have this negative here. So remember that there is negative here. Minus what? The sum of root, that's 11 out of 3. S plus the product of root, that's what? 2. Simple as that. Easy as that. So let's do another example. So this is our equation. Let's make the equation 9. If multiplied 3 through, this is what we get, right? So let's do another example here. Our roots are 4 and 1 on 2. Try this one for me. Okay, so solution. Our sum of root will be what? It means that 4 plus 1 out of 2. So sum of root, 4 plus 1 out of 2 is 9 out of 2. Because 2 times 4 is what? 8 plus 1, 9. So 9 out of 2. Simple. And our product of root, 4 times 1 out of 2. So this one will be 4 times 1 out of 2. This one will be 2. Therefore, our equation is x squared minus 9 out of 2. That's all. The sum of roots plus our product of roots equals 0. So you just substitute into the equation that we put over there. So you said that x squared minus the sum of roots plus our product of roots. Simple as that. Subscribe to Senior Policy, my YouTube channel, for more videos. Bye bye.